is the main file you have to work with, and these are types, as I mentioned before, and you have to complete the definition for these outside the class, similar to these functions, methods I have given you, and whenever possible you should use these functions, invoke them in your code. This is your file on stream. It's on stream, I told you. It's called skeleton.h. You have it available. And there are 3 data members, as you can see here. This create and create overloaded with 2 arguments and copy are private methods. The class, every method in the class can use them, but you can't use create in main because it's not public. So create or create this one, or copy a vector, you are not allowed to use them in the main, but you might need to use them in your implementation of constructors or assignment operator, because as you can see here, you have to implement the assignment operator, copy assignment operator, and the move assignment operator. You have to implement copy constructor and move constructor. And we talked about this when we talk about dynamic memory allocation. You have good examples with the array type class, or so you have to write code for this. For index operator, which comes in non-constant and constant version, you have to implement them. And then they don't require a lot of information. It's good to try to make some checks that I is less than the size and display some messages. This is not the case. You don't have to implement exceptions for this type. If you do, that's fine. You can trigger exceptions, that's okay, but it's not a requirement. I wanted just a simple way of dealing with this type, which for some people it's quite complex, as it is. So you can assert that I is less than size, and then you put a code, assert I less than m size, and performs the operation. So implementations for these, then you have pushback method, which requires some explanations. Erase is one element, the one to which P points, and then return this P by pointing to the shifted element, as I mentioned yesterday. Resize, good commenting, and you know, clear means set the vector to 0. Be aware that you shouldn't have memory leaks for clear. Empty, just check for size 0. So if the size is 0, it means that your vector is empty. Otherwise, it's not empty. Size is just returning the number of current elements in the vector, in other words, n size. So some of these functions are quite simple, one statement or 2 or 3 the most. Begin, it's just returning the pointer to the beginning of m data. Return m data, it does the job. So it's again one simple thing. Return the end, you have to look at m data plus the size. And this will take you to the first element outside the vector, so another one element. And constant, you have the same code, but because you put it constant, then it can be used with constant vector objects. So be aware, in order to test these constant methods in the main function, you might want to know whether I had added a constant vector. It would be good to say constant vector v1 after you test other things, and then call your index operator. So it's your responsibility to check all your method in the class. I have put code for some of them, but I haven't put for constant, so you can have fun. As you can see here, add more test cases. It's your responsibility to test every method in your class, and we will try to do some testing as much as possible. Any questions, please, for your assignment? Any questions? So you have this file. You don't send this file. You just send this file after you fill in the missing places, missing methods. Once again, you have to work only this part, and then everything in this part. Don't change anything inside the class if possible, and this will be possible. You might change it, but if there are no good reason for change, you might get some problems in marking. So if there are any questions, ask by email, preferable before Sunday morning, and ask in the lab, ask now to. So it's not much time left, but I have talked about this for a while. Any questions? Right. There. And I will put up the optional assignment as next week we will cover the material. Yeah, we have started talking about Java. By now, hopefully you have installed Java JDK on your computer and you can work with that. We covered primitive and types and reference types, operator strings, and we briefly looked at the array, and we have seen that array in Java are reference types, and they have to be declared using new. They can have different size when you are working with rectangular arrays. Because they are reference types, in other words, implemented with classes, they come with a lot of facilities. One facility is member data, a field which gives you the number of elements. So this is not a function, this is a member field. It's very efficient to invoke it like this. So the name of the variable is array, and it's a float of 10 elements, and whenever we do something, after we initialize them, the elements, then we can work and display them. If we don't initialize them, as I mentioned before, they are initialized by the default values for the type. For primitive types, they are for float 0.0 and so on. For reference types, null is the default value. Be aware, null. So you don't print those. Because of having this extra information coming from classes, Java is able to check that we don't have silly mistakes. And their way to let us know that things are wrong appears at runtime with exceptions. And we have seen that if this array of 10 elements try to work with something outside its bounds, out of bound exception is triggered. And normally the arrays are quite well documented by their names. One reason names are long, explain everything, plus they can't be by mistake introduced in the scope with your variables. You name a variable array index out of bounds exception, this is most unlikely. Because arrays are references, when you assign an array to another array, you are working with pointers behind the scene. So copying, which means deep copying, it's a different story. Right. So be aware, and we will see this approach for most types. If you have an array variable A1 pointing to this array of integers, and then you have A2 pointing to this array of integers. If you say A2 is assigned the value A1, what happens? This goes here, because what you do, you work with references. It's no problem with memory leak because this is handled by the garbage collector, but you might not want to have this situation. All you might want is to have A1, which was, let's say, 4 elements, and A2 with 3. You want to do copying. This element goes there, this element goes here, and you want an extra data to do copying. So this is what we have for deep copying in C++, right? 1, 2, 3, 4. We want to end up with 1, 2, 3, 4 with the same elements. So to perform deep copying,